All right, number 22. Angles F and G are complementary angles. As a measure of angle, F varies from a value of x to a value of y. The sine of F increases by 0.2. How does cosine of G change as F varies from x to y? Well, this seems extremely confusing, so I want to draw a picture. So on my picture, I'm going to draw a triangle, and the reason I'm doing that is because I know sine and cosine we use for right triangles. So I'm going to call one side F, the other angle G. So the two angles are F and G, and I know that they are complementary. So I didn't pick the right angle because if this is 90, I know a triangle is 180. So 180 minus 90, that means F and G must add up to 90. So that's how I knew it was those two angles. Now, I don't know which one's bigger than which, but I don't think that matters for this. Now, let's do it for instance. Let's go ahead and call each of these points, we'll just call them, I'm going to call the right angle angle H. And then I'm going to call my points, they can be, we'll say, I'll make it consistent. So this will be A, B, C for my actual points. So I could say for this, it says the sine, where was that? Sine of F. So if I say sine of F, I'm talking about, remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. So opposite of sine of F is going to be BC, and then hypotenuse is going to be AB. And then look at what cosine of G is. Cosine of G is adjacent, so adjacent to G is going to be BC, and then the hypotenuse is AB. I want you to look at the relationship we just figured out. The sine of F gives us the same exact answer as the cosine of G. It's the exact same two sides for both of them. So this is the exact same value. And I want to further test this. What if angle F was 60 degrees and angle G was 30 degrees? Are you telling me that the sine of F is the same thing as the cosine of G? Well, you have your calculator. Make sure your calculator is in degree mode. And I want you to see this relationship. Type in sine of 60, and I'll prove that this is the same. So sine of 60, we're in degree mode, gives us 0.8660. And then if I type in cosine of 30, that gives us 0.8660. So that's a pretty neat relationship we just found out. Whoops, that was cosine of 30. So if we take the sine of an angle and then the cosine of the complement, that's what 30 is, it's the complement to the angle, they're going to have the same exact value, always. And you can try it with another relationship. Like, what if we were to say, instead of 60 and 30, we could have called it 70, and the other one would have to be 20. So now try sine of 70. See what you get. Sine of 70, this always works. So sine of 70 gives us 0.9397. And then try cosine of 20, and you get the exact same thing. So what we just found out is the sine of F and the cosine of G are the exact same value. So if the sine of F increases by 0.2, then we know that the cosine of G is going to increase by 0.2 because they are the same exact value. So they're going to operate the exact same way. So it increases by the same amount.